The Martian Dream. How we'll colonize the red planet. The fascination with Mars, its key characteristics, red color, thin atmosphere, cold, temperatures, and why it's our next target. A brief look at our historical obsession with Mars, from ancient stargazers to modern sci-fi. The why. Discuss the key motivations for colonizing Mars. Understanding the planet's geology, potential for past life, and the origins of our solar system. Creating a backup plan for the human species in case of a catastrophic event on Earth. The incredible innovations that will be spurred by the challenge of Mars colonization. The journey to the red planet. The physics of getting to Mars, including the Hohmann transfer orbit and the concept of launch windows. A look at the next-generation rockets needed, such as SpaceX's Starship or NASA's Space Launch System, SLS. The challenges of a long-duration spaceflight, radiation exposure, muscle atrophy, and psychological effects. The 7 minutes of terror, the perilous descent and landing process in the thin Martian atmosphere. Detailed look at the technology required for the journey. Discuss next-generation reusable rockets like SpaceX's Starship and NASA's Space Launch System, SLS. Explain the science behind a 9-month Hohmann transfer orbit and the importance of launch windows. Building a home from scratch. The first habitats, likely inflatable modules or landers, repurposed as shelters. The critical concept of living off the land. Water ice. Using robots to locate and extract water ice from the polar regions or subsurface. Using regolith for 3D printed structures, radiation shielding, and as a component for building materials. The use of solar power and potentially nuclear reactors for a stable energy source. The Martian pantry. Growing our food. Growing food indoors in controlled environments without soil. The lack of Martian soil nutrients. The need for a closed-loop system for water and air, and the effects of lower gravity on plant growth. The possibility of genetically modifying crops to thrive in the Martian environment. Discuss the need for a diverse diet and the potential for protein sources beyond plants, such as cultured meat or insects. The long-term goal of becoming completely self-sufficient in food production. The air we breathe, Mars' atmosphere, is over 95% carbon dioxide. The use of the MOXIE instrument, Mars Oxygen In-Situ Resource Utilization Experiment, to create oxygen from the Martian atmosphere. The need for closed-loop life support systems that recycle oxygen and scrub out carbon dioxide. Tie the air and water systems together to show how they form a single, integrated life support ecosystem, a miniature version of Earth's own biosphere. Staying healthy on a new world, shielding habitats and spacesuits from cosmic radiation and solar flares. The long-term effects of 38% Earth gravity on the human body, including bone density loss and muscle weakening. The need for on-site medical facilities, telemedicine from Earth, and a robust understanding of Martian-specific health issues. The Martian economy. How the colony will move from being dependent on Earth to being economically independent. Mining of valuable resources, manufacturing of spare parts, and scientific research. What goods will be exchanged between the two planets? Terraforming Mars, a vision for the future. The concept of transforming Mars to make it more Earth-like, using orbital mirrors or greenhouse gases to warm the planet, releasing trapped CO2 to create a thicker, more protective atmosphere, melting the polar ice caps and subsurface ice to create oceans and lakes. The enormous scale and time frame of such a project, hundreds or thousands of years. The legal and political frontier. How current international law applies to space exploration and colonization. The challenges of establishing a government on Mars. Who will be in charge? The legal and ethical questions that will arise as the colony becomes more permanent. The first generation of Martians' daily life for colonists, including work, leisure, and social structures. How a unique culture and identity will emerge over generations. The challenges and ethical considerations of having children on Mars. Psychological resilience. The mental health challenges of living in a small, isolated community millions of miles from Earth. The profound psychological shift that comes from seeing Earth from space. How technology will bridge the communication gap with Earth. The robots that pave the way. The role of robotic missions like Curiosity and Perseverance in gathering data and preparing the site. Autonomous robots that will build the initial infrastructure. How humans and robots will work together to build the colony. Addressing the skeptics. The enormous financial investment required for the mission. The high probability of failure and the dangers to human life. A philosophical discussion on the value of a multi-planetary future versus addressing problems on Earth. From colony to city-state. How the initial outpost will grow into a large, self-sustaining city. The development of internal transportation, waste management, and communication networks. What new technologies will be created by the unique challenges of a Martian city. The future of humanity. The long-term vision of a human civilization spread across the solar system. A concluding message encouraging a new generation of scientists, engineers, and dreamers to make this vision a reality. A powerful, concluding statement that inspires viewers to become part of this journey, whether as future pioneers, engineers, or simply supporters of this grand endeavor.